My name is Rolf Hilfiker. I am the Chief Executive Officer of Pneumofore, and my focus is mainly in administration and sales.
I'm Daniel Hilfiker, and I am the president of Pneumofore. My focus is the engineering part.
If I'm a can maker working in a can plant or in engineering, what should I know about your role?
We are experts in pneumatic machinery. This includes both vacuum pumps and air compressors, and we supply since decades worldwide two-piece can plants.
Pneumofore works in a lot of different industries. Can manufacturing is one of them. What do you find interesting or unique about working in the can industry?
It's an incredible, fascinating process which require immense knowledge in materials, in thermodynamics, in fluidodynamics, in many other things and fields.
I'm also overly impressed with the professionals that work in the can industry.
What's very interesting from our point of view is that the can industry is one of the main consumers of vacuum. There is almost no other application which needs the same amount of vacuum.
Just for reference, what are some of the other industries that Pneumofore works in?
The other industry which uses a lot of vacuum is the glass industry, bottles, jars, and so on. But the importance of vacuum in the can industry is even bigger. Without vacuum, you don't run the production.
So vacuum is used in many places in a can plant. So let's pick the decorator as an example. Can you take me backwards, starting at where the vacuum is used to hold the can on to the mandrel, and explain step by step how vacuum reaches this point?
The vacuum reaches that point by means of a pipeline. The pipeline has to be designed in a way that the flow and the vacuum level is correct for exactly that operation. Now, where does the vacuum come from? The vacuum pipe is connected to a manifold, and the manifold goes back to the centralized vacuum. Inside the vacuum room, the vacuum is generated by vacuum pumps. They are boxes, look like many other machines, soundproof with a closed oil circuit, and they have electrical panel, power supply. But the heart of the machine is the technology. In every box, there is mostly one air end, preferably air-cooled, based on rotary vane technology. This is our expertise. We do this more than 100 years. And in the rotary vane air end, we have a rotor which is displaced to the housing. This rotor has the slots. Within the slots are the vanes. The vanes give the name to the rotary vane technology. Now, if you can see the picture, this rotor is moving now clockwise, and the volume of the chamber is reduced due to the axial displacement of the rotor towards the internal housing. The air comes in by the big inlet, and there is a large quantity of coolant which is also entering the air end in order to lubricate and cool down the air end constantly.
This is the air inlet, and the air gets cooled as it enters here into the first chamber between the rotary vanes. And then as it rotates clockwise, the air volume is decreased, and that is what actually generates the vacuum. Is that correct?
Because we extract air from the pipeline, and therefore the pressure in the pipeline goes down, and we have to do it constantly.
You mentioned, Daniel, that these systems are air cooled. Why is that an advantage?
We have a lot of customers in tropical countries or in altitude. A water cooling system implies water pipes and water pumps and cooling tower or chillers And this is, first of all, additional cost to build it up. Second, additional electrical consumption to feed all the circulation pumps and the cooling towers. And third, because the water is not always clean, usually there is a reduced cooling capacity of the cooling system made by water. Therefore, people prefer air cooling to the water cooling.
Can you explain the difference between generating vacuum through screw technology and rotary vane?
The screw technology, they are actually a bit different. They have no active sealing as the rotary vane technology because they have two rotors, a male and a female rotor, which typically run at much higher speed. We talk about 4,000 or 6,000, 8,000 RPM, depending on the frequency. And due to the limited space of having two rotors, these bearings are automatically smaller, and the bearing size determines the bearing life.
When we talk about the bearing size, this is where the air is captured, and we obviously have to have these two in close proximity to each other, and that is why we are limited with this technology to the bearing size. Is that correct?
Very correct. Now, the synchronization of the rotors happens with a gear. But frequently, the drive is only connected to one screw, and this one screw pulls the other screw behind. These bearings need to guarantee the non-touching of the screws. Very important. The screws do not touch. The gap between the screws is filled with an oil film, but by the continuous operation in a can manufacturing plant, there is a risk of the screws touching. And therefore, the overhauling the screw air end is recommended every 3 to 4 years. And this means replacing the bearings. And if you don't do so, then the screws touch and then you have to replace the entire air end. Now, this kind of operation is very expensive. Our philosophy is different. We want to give a reliable, durable air end, which is efficient on the long term due to low rotation speed, low temperatures, hugely dimensioned bearings, and vanes made of aluminum, not some consumable material.
You mentioned here in the alternative style of vacuum pump, you have 6 bearings. How many bearings exist in the rotary vane technology?
We have two large radial bearings. These bearings also make sure that if there was any consumption in the bearings or in the vanes, or if the maintenance wasn't executed correctly, there is an adjustment in the movement of the vanes to always guarantee the active sealing.
Is there anything else that is worth mentioning about the Pneumofore rotary vane style vacuum pumps?
The rotary vane vacuum pumps of Pneumofore have been designed with the idea of offering the lowest total cost of ownership on the market. So when we make a quotation, we also add the cost of the spare parts, and we add the guarantee for the values of efficiencies. When the customers look at the total cost of ownership or the life cycle cost, or if they want to rent the system, then Pneumofore is also the cheapest by far. So we rent successfully our vacuum pumps worldwide almost, because we know that the monthly fee is a fraction of the competitors, because we know that we don't have to overhaul the air end and we don't have to spend a lot of money for the maintenance of the machine.
Rolf, is there anything else you'd like to add?
Our motto is install it and forget it, which doesn't mean don't do the maintenance, but it shouldn't be a daily topic. And our purpose is to make it possible for our customer to install the machines and forget them with the smallest possible CO2 production.
I want to thank both of you for joining me today and sharing your knowledge and we'll look forward to speaking to you again soon.